Hi, I'm Steve Bjork. I'm the author of LambdaSharp. And today we are diving into deployment configuration. So specifically Cloudformation parameters, what they can do, how to use them, and then how to deploy code with them and setting them and so on and so forth. So kind of a critical part. Previous sessions, we talked about how to compose services and the various ways that we can build and share modules. So now we're talking about how to deploy them and configure them. So there's a few areas I'm going to be touching on. So first, talk a little bit about Cloudformation parameters. It's actually a quite rich subject. Cloudformation has been around for a good chunk of time, and they've added a whole bunch of things over the years. Some of them you should use, some of them you should probably not use. They seem to be more like science experiments that they keep around for backwards compatibility. There's a feature in LambdaSharp, which I labeled resource as parameter, which is more about making kind of easy to introduce changes into a legacy environment. So I'll touch on that. Secret parameters. So these are encrypted values, super important, password, access tokens, anything basically you don't want to ever be shown in plain text, and how to work with them in LambdaSharp. And then lastly, the parameter file. There's actually a format for it. It's also YAML-based, like the module file, and there's some functionality in it, which makes it a little bit easier to make these things dynamic, environment-based. So we'll take a look at that as well. And of course, on each of these, we'll be looking at some code deploying modules, and then taking a look at what they look like in the AWS console. So let's talk about Cloudformation parameters. So LambdaSharp module parameters are an extension to Cloudformation parameters. So everything you can do with Cloudformation, you can do with LambdaSharp, and then there's a few extra things. But let's cover the basics first. There are 4 basic types. Strings can be any value, empty string to a certain, any number of characters. I think there's a limit around 4,000 character limit. Numbers, they have to parse as numbers, valid numbers. They can be floating point numbers, integral numbers, that sort. Comma delimited list, very simple. Simply Cloudformation will split the string on commas and then provide an array of values. And then list number, which is the same concept, but each of the entries in that array has to parse as a valid number. So pretty straightforward. Internally, Cloudformation, even though it thinks of things like strings and numbers, it seems to be, and the rules are not super clear, but it will auto-cast strings to numbers, things like that. So for example, the list number type, when it gets exploded into an array, is actually an array of strings that have the number string in them. And it seems to be just doing auto-casting. That has been my experience, and I've never seen where actually the type mattered that much, other than that it had to be able to convert then to a number when a resource property expected it. So this is how the notation works in LambdaSharp. When you specify a parameter, you use the parameter declaration, you give it a name. There's some additional decorations here. I'll talk about that in a second. You give it a type. So this is where you have number, comma delimited list. And then you can reference the parameter just using the ref notation. For example, here we're setting the display name. The other parts that are part of the parameter declaration are the description, the section, and the label. The section is a construct that allows you, if you have multiple parameters and they pertain to different parts of your module, you can group them together by section. So they just have to be the same string, and they will get grouped in the order that they appear inside the file. The label is then a hint that is shown with the parameter, and I'll show you how that is displayed in action. And then lastly, the description is actually a text that is associated with the value when it is exported, like as a scope to the stack or publicly, so it can be used by other modules. And then that string is associated with. So description is really more the outward-facing description, whereas section and label is about the configuration. So this will make a lot more sense once shown in action. So as before, there's a GitHub repository. All the examples I'm going to go through are there. So let's start with the basic parameter type example. And let me zoom in a little bit here, so it's a bit bigger on the screen and easier to see. Open the shell, and then also go in here. So what is this? Basic. Oh, yeah, great. So this is exactly the example I just walked through. So I already have a deployment here, so I'm ready to go. So the only thing I need to say is /deploy. This will compile the module into a Cloudformation file, upload the asset, and then, that is unfortunate that my Zoom controls are right in the way. I can grab them. Here we go. And as you can see at the bottom now, it shows sample parameter settings. That is the section title that we're provided. It's shown in all caps. It shows the name of the parameter, the type of the parameter, and then the label that we associated with that parameter. So that is shown here interactively. What happened is we didn't specify a parameter file, yet our module needs some parameters, so it goes into interactive mode. To avoid obviously blocking a CI/CD pipeline or something, there's a flag that you can provide called prompt as errors, which means that if for any reason the tool tries to prompt something, it will instead error out. Just prevents anything from hanging indefinitely because it's running off screen. So we're just going to give this particular SNS topic the display name of hello world. With enter, it's part of the configuration of the deployment. And the stack is being created now on our account as we would expect. So let me go back to that. And that should be on this tab here. So if I hit refresh, we see that the deployment config basic parameter type stack is being created. It's creating the SNS topic. And this is pretty fast. SNS topics get created pretty quickly. If we look here, we can see that the display name is hello world. Maybe zoom in a little bit. So it basically read the parameter, passed it on through the reference construct, and it's set as you would expect. Now, the decorations we did with sections and labels, they helped on the CLI side, but they also are present here in the AWS console interface. So if I go to update stack and use current template, we're not updating anything else. It allows me to edit the parameters. And just like we had it on the CLI, the section is shown here. This is actually a Cloudformation feature. It's not super commonly known, apparently. I don't see it in many examples, but it's amazing. We can describe the user interface and how we want to organize our parameters for a stack. So in case something does need to get updated in the field without rerunning the whole CI/CD pipeline, we can go here, we can provide some context. Like I said, this is the label we showed earlier. This is the section. As you can see, there's additional sections. These are built in automatically and generated by LambdaSharp. For example, such as, do you want LambdaSharp core services enabled in your deployment? And you have enabled, disabled. So here you can edit these values. And then everything below, like it indicates, this is actually LambdaSharp takes care of this, and it's part of integrating, so they shouldn't be edited. But your own changes can just be reflected here. And then I can just change the string. I go to next. It asks me if I want to do it. I say yes, 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 yes. All kinds of other settings that can be updated. With update, now it reruns the same template. There are no changes to the template. So if the template has been validated that it is correct and does all the right things, all you're doing here is just applying different parameters. And this should be pretty quick. Yep, update complete. So now if I open this, hello world again. So pretty straightforward. So those are just how basic parameters work. And it is pretty much without, there shouldn't be many surprises here, hopefully. So let's go back to what else we can do with parameters. But I think what is cool, though, is the fact that you can talk about presentation layer, the logical organization, and how the CLI as well as the console use that information to provide a better experience than just listing parameters without context. Oh, that reminds me, I did forget one, the outputs. As I was mentioning, the description, here's where it shows up. So this is the topic display name. We said we wanted it to be scoped to the stack, which means it is available as an output value. This is the value we have. And then here's the description that we associated with it. But that's just touching on the tip of the iceberg, because in addition to just to specify those basic types, we can also annotate constraints on the parameters. One of the more popular ones, I think that's really powerful, is the allowed pattern. Applies only to string types, but you can then say that, for example, that you expect the names to be only lowercase. Let's say you want to take an S3 bucket name that you're going to create, and for some reason you don't want it to be generated automatically, which is the recommended method. There's a use case for that from time to time. You could specify here that, for example, you only allow lowercase characters, lowercase and numbers. That's the only thing you can use in bucket names. Otherwise, the bucket creation will fail. Allowed values is actually very much what you just saw a moment ago, where we have enabled, disabled. So you list the values that are allowed, and the CLI will show them, as well as the AWS console will show that you have to enter one of these choices. Those are the only acceptable values. Default, as the name implies, if you do not supply a value for this parameter, it will assume this value. Now, there's one caveat with default that's important to know. If you publish a template, let's say you gave it a default of 100. So it's a numeric value, default 100. And the next time you publish a new version of the template, so a new version of the module, and you change the default to 200. So for example, this could happen with your LambdaSharp functions, where you want to have a default value that gets passed in, and you want to make it configurable, as opposed to, as we do it right now, which is more specifically set. When anybody who has deployed that module and created a Cloudformation stack, it will look like that default value was specified. So even though a new stack is being deployed and it's updated, where the parameter has a default of 200, Cloudformation will see that you had specified 100 and will keep it. So defaults are not automatically updated. So that's just a caveat. It's kind of important because you could assume, as I did, that if I change the default, then it will, and it used the default last time, it will upgrade to the new default. No, it does not. It keeps the value from the previous default. It doesn't change until you have to explicitly provide the value in order to have it changed. Min lengths, max lengths, it's a character limit. For example, you want to make sure not an empty value gets entered. You put min length to 1. You don't have to specify max length if you don't want to. If you know that you have a length constraint, some resources, for example, you can't give strings longer than 64 characters, depending on, like, if you give it a name itself. So you can put in this limit. And again, this just provides early validation long before anything else runs, because that resource could be created fairly late in the stack creation or update, and now everything has to be rolled back. So doing this early validation is really powerful. Min value, max value is exactly what you would expect it, applying to numeric values. And then last but not least is no echo. This is actually a very interesting one, and one that LambdaSharp uses automatically for secret type. And I will touch about that in a moment. But it basically, as you'd seen earlier, when the stack output, it was showing the value of the input parameter, right? It was showing hello world again. If we had set it to no echo true, it would just be showing 5 asterisks, and that is it. And that is true for CLI tools, for the API, and the console. It's just that value is no longer retrievable because it's expected to be a sensitive value, and it should not be shown. So this is whenever you pass in sensitive information, you want to use no echo. Now, the LambdaSharp secret type, which is specifically designed for encrypted values, does it implicitly. However, for any reason, you may not want to use that mechanism. Make sure if it is sensitive information, use no echo true. Great. So then we go here a little bit what I was calling earlier the science experiments. There's about a dozen of these AWS specific parameter types. And I think they're pretty cool, but they clearly stopped adding to them. Now, I pointed out a few here. There's more. Like I said, it's about a dozen. But because these actually apply to serverless. The other ones had to do a lot with like EC2 instance ID or instance to image ID. It's like just not, that's not serverless. So, but for example, if you have a module that takes a VPC ID, you could use as type instead of string, you could actually say AWS EC2 VPC ID. And Cloudformation will validate that the VPC ID that is being passed in is an ID of a VPC instance that exists. If it doesn't, it will fail. You will never get to the other parts. So it's kind of a neat feature, and I'm kind of a little bit saddened that they haven't kept up with it. But I can also see it with the explosion of resource types that they have had, it would have been difficult. That said, these ones are available. I think they're very convenient. Specifically, the VPC ID, the subnet ID, and the security group ID and group name. There's a composite version of this as well, where you can say list, for example, of subnet IDs. So it will validate that every ID in the list does exist. And again, upfront validation early on, I think, is always very powerful. And so that's one of the capabilities that Cloudformation provides with these types. When you look for AWS-specific parameter types, probably your top hit will be the page where they list all the parameter types of Cloudformation, including these. Then we have these guys. And maybe if you watch some of my videos, when you know I take a deep breath and take a pause, it's probably because it's my favorite topic, the SSM parameter type. So these have to do with the parameter store. systems manager parameter store. I would not recommend using them, but so just they exist and what you can do with them. So similar to the AWS specific types, they have much more complicated names. This one here will validate that the value of the parameter corresponds to a parameter key in the parameter store. It doesn't do anything with it. It just keeps that name. So it could be /foo/bar pointing to parameter store value, and we just make sure that it's a valid value. A little bit like the VPC ID did for AWS specific types. Parameter value string does it slightly differently. You still specify /foo/bar and so on, but it will actually read the value at that location from the parameter store and make that available as the parameter value. So it's almost like a conversion, right? Because the value you passed in was the path to the parameter store value, but when you then ref on that parameter, you actually get the value from the parameter store, not the name of the key that you had passed in. And the type in between the angular brackets is what you expect to be. It's a string, a list of string, which means, again, it will be parsed in commas and exploded into an array. These two are equivalent. You can also do it that you expect that to be a VPC ID, for example, which it gets really interesting, or a list of these. So now you can stack them in really interesting ways. One thing to know, though, is that all of these do not support secure string. So that's the encrypted version of a parameter store value that you would want to use for passwords and things of that. So you're dead out of the gate if you wanted to use it for that. But in general, I would just say just abstain. This seems to have been an early idea of how to bring in parameter store capabilities into CloudFormation, and you just abstain from using them. But if you come across, you should know that they exist. And if you have the opportunity of refactoring the template or the module, by all means, you should probably do so, because the right technique is this. It's called dynamic parameter references. And it does the same thing, except it does it by using these kind of like odd expressions. For example, if you give it the value of resolve : SSM : S3 access control, it will find in the parameter store the S3 access control field, and this can be, again, /delimited path into the parameter store, and resolve that to a value. So it does the exact same thing as the second form here, the value string. But the nice thing is it is a regular value you passed in. So you can think of it now, you have a regular string parameter, and you could give it the value foo, right? So it goes with that value. Or you could give it this dynamic reference, curly, resolve : SSM, as the parameter value, and it will actually look it up in the parameter store. So it's much more flexible, right? The previous technique where they had the specific type, it had to look up in the parameter store, it had to look up at a certain location that you specified, and it's just not the greatest way to do it. This is much more flexible. You can pass in an explicit value, you can pass in a reference to a value, and it works. And it supports also the secure string resolution, as well as secrets manager, which is, I've had limited experience with it. From what I've seen, though, and how they're organizing it addresses some of my concerns with parameter store, so it's worthwhile further exploration, but all of these are supported. Now, there are some caveats with secrets manager and secure, which is secure string. Custom resources cannot get them, period. They're just not supported. The other one is the SSM secure. It's a very specific list of AWS resources and properties that actually can resolve these. This is not something that is generic, you can use just anywhere. It's almost like certain teams on certain properties on their types, so basically provided support for this resolution. I still believe it's your stack that has to have the decryption access to the parameter store in order to decrypt it. I've never tried it. It's just super limiting. It's not great. It seems like Secrets Manager doesn't have that same problem. Another thing I wanted to draw attention to is I have seen this in the wild in examples. I don't know if there were examples shared by AWS, but it's possible. But look out for this, where somebody in their template put a dynamic expression that resolves, that basically constructs one of those resolve strings that then get evaluated. The lookup happens, and they take as input the name that they want to resolve. This makes no sense whatsoever. Why wouldn't you just have passed in this expression to begin with? Because this one, again, binds you that it has to be SSM. You can't even choose between SSM secure or secrets manager. And you can pass a specific value in it either, like a fixed value. So it's just a really terrible anti-pattern, but it is out there in the wild. If you see it and you copy paste some code and you adapt it, take it out. It's terrible. It's just not future-proof at all. So instead, you should just pass in a dynamic parameter reference. It's a much cleaner way if you want to use secrets manager or parameter store. Again, that's a big if. Now, what I would have said at this point is that you can see these numbers at the end. That's the version. Every time you update the value in parameter store, it creates a new version. So if you say :2, it will pick the second version of that value in the parameter store, even though you may have created a third, a fourth, a fifth. That has certain benefits. It's that you know exactly which value it picks up. So that's nice. It is tedious, and there has been a big complaint from the community, because now if you do publish a new value in parameter store, you have to go in and bump all the places where you were using it. So as of today, where this video is being recorded, they made that optional. So that's brand new. That was never the case. It was always the case, and that's been a big friction point. So now you can actually drop the :2, and at the time that this expression gets evaluated, it will resolve to the latest version in the parameter store. Now, the way Cloudformation works, and I haven't tested this, but I know that from past, unless they change the behavior, the reason why it would evaluate something is because it sees the value has changed. What I don't know is if you just change the value in parameter store and you rerun it without the suffix here, because the suffix would have indicated there's a change, it would have evaluated it because it's different and updated the resource. What I don't know is if maybe they're now running this a little bit early in the process and they see that the value in the parameter store has changed, and therefore they will update the resource. They only update things where they track changes to values. That has been true historically. This might change that. So just, you may want to test it just to make sure it picks up what you expected, again, if you're using parameter store. All right. So that's the foundation. So we spent a little bit of time on it, but as you can imagine, it's a pretty wide foundation, and understanding it and knowing kind of what are the tools that are available is important. So let's talk about this little one, this little funky little thing. This is specific to LambdaSharp, and it looks a lot like a regular parameter. The first thing you might notice is like it no longer says my topic display name, it just says my topic. And the reason is we are actually not talking here about value properties anymore, but resource properties or resource parameters, really. Specifically, the two things that stand out, the type is now the type of an AWS resource, and we have a properties section. So what this does is it basically allows us to make a resource, to either create a resource that we've pre-specified, or to have the ARN of an existing resource be passed in. So for integrating with legacy systems, this is a really nice feature, and it makes it just very flexible. Again, the best way to probably see how this works is to just run an example of it. So let me go to the right folder. That's later. So this is the module for creating this resource as parameter. Resource parameter, great. So now if I run lash deploy, and this is very, very simple, but the change here is that we're not providing the name of like the display name of a topic. It's the ARN of an existing SNS topic. And if we leave it blank, which is like the string indicates up here, it will proceed and just create a new one. And internally, wherever we have a ref to my topic, it will automatically expand to either the parameter if it is specified, or the ARN attribute of that resource if it exists, if an ARN attribute exists. If it does not exist, it will just default to the ref of that resource. So it does an internal lookup against the attributes that exist on all the possible types and see which notation it should use. Okay, we created that. So let's go back in here and just filter. So you see the stacks we're creating. Okay, so this is the resource as parameter, as I mentioned. When I look at parameters, we can see that we didn't pass in anything for my topic. And oops, I'm just misclicking all over the place. The resources, we'll see that my resource was created. It's an SNS topic. And on the output, since we exposed it, we also see that it's being exposed as an ARN. So whenever you use resource as a parameter, you no longer have a resource that you operate on it. You can't do a get attribute and any of these things, because it has to be agnostic of, is this an ARN that's getting passed in as a parameter, or is this something that was created as part of this CloudFormation stack? That said, though that is one limitation, and it can't be helped because of dynamic, you can still assign permissions to interact with it. You can, if it's like a topic, you can have lambdas listening, subscribing to it, because all these operations use ARNs anyway. So wherever an ARN works, you can just use it. Now, if you do need to have access to the attributes, then this is not a suitable mechanism. But for example, a great use case for it is if, for example, you wanted to have you have a module and it creates a whole bunch of SNS topics that are being used for other Lambda functions to subscribe to via the import mechanism that we covered in the first session, you would probably create a module that just creates them. The problem is, if that pattern already exists, then you now have to do a migration. So an alternative would be, hey, for environments where maybe this has never been deployed before, great, deploy it by creating the resources and do it the right way. For legacy environments where maybe the topics were created, this architectural pattern had been embraced already, when you deploy the module, give it the ARNs of the existing topics. They will now be exposed just like everything else, and you can wire everything up downstream just the way you would have done it anyway. So it kind of creates a nice little bridge piece. So it's a very specific functionality, and it does a bunch of conditional logic behind the scenes that you definitely never want to have to deal with. But why miss the opportunity to take a look, right? All right, so let's see. So the parameters are here. My topic is the parameter, the resource that we're taking. And now we can see there's on the resources, there's a my topic resource. It has a condition only if my topic is blank, does it actually get created? Condition a little bit further down in the file. I'll cover that in a second. There's also an output section of which value should be outputted. Well, that depends. If my topic parameter was blank, then let's output the ref or the ARN of the resource that we created on behalf of the user. Otherwise, we emit the value that was passed in. And then my topic is blank is just the comparison function on my topic to see if it has a blank value, and then we can do the conditional logic on it. So that gets done behind the scenes, and then all the refs are also being rewritten accordingly. So a little bit of magic, but very, very convenient. It works pretty well in practice. Great. Okay. On to the big one, secrets. Okay. Hello. All right. There's a couple of components. One is, so LambdaSharp introduces, and I don't know if did I highlight it? Oh yeah, not quite, but I missed one. I did. Introduces a type secret. I should have highlighted this one as well. And you can use these parameter values of type secret are in KMS encrypted values. And in order for the stack to be able to decrypt them, it needs permission to do so. It needs access to KMS decrypt on the key that was used for encrypting these values. That you can do that with so two means. One is you can embed it into the module directly. This is kind of like an old mechanism. It's good for testing. Just you should not do this in a production environment, because then you're account bound. You would actually have to have that key on this alias. You can use an ARN that's even less portable. You can use an alias, but then it would have to exist so you can map it. It's not very convenient. There's a way to pass it in dynamically. That's the recommended approach. But for illustration, I use the embedded approach. But we have to give permission to the stack to use that key for decryption purposes. Lambda functions automatically know how to decrypt them. We'll take a look at that second. And then you have a notation. If you need to pass this into a resource that needs it, it's a password, it's an access token. For example, Alexa uses access tokens. You also don't want those in clear text. You would need to call ref on the parameter that is a secret, and then append : plain text. And that does the decoding and passes in the plain value. As mentioned before, this is automatically set to no echo, so it's just completely transparent and omitted. Okay, so let's take a look at that, because that's kind of a cool one. And super important, you should always make sure that you take care of keeping your important data safe. Okay, so for this one, we're going to need to pass in, let's open the module. I'm going to close the old one. Okay, so this parameter is marked as secret, which means it's going to expect us to pass in an encrypted value, right? That's fundamentally. It is otherwise pretty much the same thing as we had before, except this time I added a Lambda function to it as well, but it's just setting the display name. So first I need a value it can decrypt. And for that, there's a little convenience function called /encrypt. It can take a file or just command line input. We need to give it the name of the key we're going to use for encrypting the value we're going to specify. And then we specify hello. That's going to run through. And here we go. So that is now the value hello encrypted by this KMS key. And so we say /deploy. It's going to take just a second longer because it needs to compile the Lambda function underneath. Uploading artifacts, boom, there we go. And as before, again, we get prompted. This value doesn't have a default. And so we paste in this long string and we have it go added. And now let's go to Cloudformation and see what's happening. Because a few things will be occurring here. Not only is it creating all the standard resources as it needs to, it's also updating, of course, the Lambda function and so on. Because we need ability of decrypting this encrypted value inside Cloudformation so we can pass it as a display name. It's not the perfect use case, but to illustrate, we actually embedding a little bit of a custom resource that does it for us. And that custom resource, like the Lambda function, has permission to do so. So you will see an additional resource being created here that you did not create, that is responsible for that decrypt, this module decrypt secret function. So that's what it is there for. And if I go to my topic, we should see that the display name is hello. So this was effectively, the encrypted value was decrypted and then passed in as plain text to the resource we needed to create. And similarly, we also are using it from our Lambda function. And if you look inside the Lambda function, there's nothing special in Lambda land that we need to do. We do our regular initialization. The parameter, just like we can do it, resources and variables, was scoped to this function. And we read it like any other. We just say, hey, I want to read this value from my environment variables that were passed in through the module definition and initialize my topic display name. And then when we invoke this function, it's just going to return with whatever that value is that it received. So going to the right, oh, it might not be there yet. We're still creating in progress, wasn't finished. Last time I refreshed. Okay, here we go. My function. So open my function. If I go to configuration, hello, environment variables, here you can see this is the value, the encrypted value we passed in. So it's not displayed decrypted at all. There's just no way of seeing it, which is the whole intent. And you can see there's a little bit of a difference at the beginning of this environment variable. Usually they start with str underscore. This one starts with sec underscore, indicating it's a secure string. And so Lambda on first initialization will decode it or decrypt it and store it. So it only gets decrypted on cold start. That's it. No decryption afterwards. And it keeps it in memory. So let's test it. We just invoke test. They made this a little bit more fluid, which is really nice. And so we saw that it was encrypted coming in. And we see here, Lambda it got the decrypted value. It did its thing implicitly. Of course, it needs permission to do so, right? That was part of that secrets thing. And I have a key here called my secret key. So that's why I just deployed without any complications. Just make sure I know what's coming next. It's quite a bit of topics. Okay. So here's how kind of like the rules of engagement around secret type, which is LambdaSharp specific. One is, like I said, no echo is true. So if we go back to Cloudformation here, I didn't even flag it as an output. So if we would have been here, it would have just shown asterisk. It wouldn't have actually shown the value. Even then, it would have been the encrypted value. So it's just extra redundancy around secrecy. Can't be too secret. You need to give the decrypt permission of the right key so that both the CloudFormation stack with the plain text extension can do its job, but also the Lambda functions. You can specify either an alias. I think that's the preferred way. It's a little bit more flexible. It's certainly more readable, or an ARN. Either one is perfectly fine. You can specify it one of two ways. One is, as I showed, inside the module. That's kind of like hard-coded. It's not super flexible. It's too rigid. The alternative is to pass it in as a parameter. It defaults to an empty string, and that's why we were never prompted for it. So, but you can specify in the parameter file, which is what we're going to talk about next. The Lambda function automatically decrypted. We have these convenient things, and then lash encrypt is kind of like a convenience function of the LambdaSharp command line utility. It has a couple of additional things. You saw how it can encrypt using the key ID that you specified, the value. You can read that value from a file, piping it in so that it doesn't, get captured in your shell history. You can also say decrypt first, which is useful when you have a secret, so you have the encoded value. You have permission to use decrypt on it, but you don't want to pass that directly to the module. And so the tool, so you pass it on the command line. Let me probably just show it. It's a little easier. So we had this string still. Yep, fantastic. So I said lash encrypt. The key is alias my secret key. Now I specify decrypt. What this will do, it will decrypt this secret using my permissions from the command line and re-encrypt the value into using the key as specified. So this allows you to kind of like change context. If you have a key, but you don't want to, for some reason, give your module access to that key, maybe it's too broad, but it can decrypt. You want something more narrow. This is kind of a convenience function to decrypt it and re-encrypt it with the new key. So that's what it did. Anyway, lash encrypt -- help, and you can kind of see all the capabilities that you have in addition. Great. Now onto the pièce de résistance, the parameter file. This is kind of where this is the method you want to use. The interactive one is kind of cool when you do your own development. It prompts you instead of having an error. So it has a lot of nice features, I think, for the developer experience. But ultimately, let's face it, it's not what we're going to be using in CI/CD pipelines, right? We're going to pass in the values up front. Now, the parameter file is not just a simple YAML document. It is actually one where you have also parameter functions in it, and they come in a few different flavors. The one that I recommend using most commonly is getConfig. This will open a JSON file and then evaluate a JSON pass expression against it to retrieve a value from that configuration file. So you can have this master configuration file that you use across many modules, and you cherry pick the values out of it that you need to configure in the deployment of this module for this deployment environment, be it production, development, staging, whichever you may have. You also can do something similar by reading environment variables and using that to initialize parameter values. And finally, if you must, and for some reason the resolve approach doesn't work for you, you can also read values from the parameter store. And there's two flavors here. The first one is it just goes to the parameter store and it reads the value. And if it's a secure string, it will decrypt the value, period. And so pass it in as plain text. So make sure to use no echo on those, because those would not be considered secret since there's no KMS mechanism around it. Instead, there would just be string with property set to no echo true so that it doesn't get printed anywhere. So that works. And because we do it ahead of time as part of the deployment, it's basically none of the limitation that we see with resolve strings apply, especially secure string. That said, you have decoded it, right? So there's a risk there. So that's why we have a second version, which does the same thing. However, in addition to reading the value from the parameter store, it encrypts it with the KMS key that you are providing as the second argument. So that is the second form here. It takes an array, pass to the parameter store key, and then either an alias or ARN of the key you want to use to encrypt the value before it gets passed in. So this is what you would use when the expected type is secret. So then you get all the benefits of that you saw earlier, which is you can say : plain text to initialize it, properties of resources when needed. Lambdas will decrypt it on startup, and so on and so forth. Finally, there's also the substitute function that also exists in Cloudformation files or LambdaSharp modules. And this one allows you to effectively build dynamic values. So you can compose things together and just create a composite value by reading an environment variable and so on and so forth. There's also a few built-in variables that you can access that are specific to the deployment. So as it is running, you access them with the ref function, just like you would do in LambdaSharp module or a Cloudformation template. And these are kind of, hey, what bucket name is being used for my deployment? Which tier do I go to? Tier lowercase, which is useful for resources that are limited to lowercase characters, the prefix lowercase, and so on and so forth. So these can also be retrieved and used dynamically, for example, with sub to create values, to initialize these parameters in a very constructive way, very natural how it works. So let's take a look of putting a lot of these together. These functions, they don't stand alone. They can feed their results into the next one. So this one, I'm not saying you should do it this way because it's a little bit complex, but I just wanted to show you the flexibility of what it can do. So here in this example, we'll actually look at it in the editor. It's more fun here. I have it more for completeness in the slides. So let me now go to the parameter file. And okay, that's what we're going to initialize. This is actually the exact same example that we started with, the basic type. We're just taking a display name, we're initializing it. But we now have this parameters file. And so what it does, it says get config. This is the function that we use for opening a JSON file to read and then use a JSON path expression to read a value from it. In this case, the name of the file is actually created by reading the target environment variable, which can be prod or dev, initializing it into a placeholder variable, and then using the sub expression to create this dynamic string. So the name of the file is dynamic, and it's driven by an environment variable. We then use this JSON path expression to retrieve the value from it. So if I open, for example, the dev file, you can see topic settings, .display name, it will pick up this string. And similarly, display name, it will pick up that string. So, oops, I'll close that one. So pretty straightforward. Okay, and then, yep, this is, I think, the parameters file I was going over. And then I just have it here. This particular example doesn't require access to a KMS key, but this is how you would specify one or more KMS keys. And so these would be then passed in as a parameter. So this is the way to do it rather than to have it embedded in the module, which is way too strict. Great, let's deploy this. So let's go to, what's the folder, parameter file, /deploy. And so now we're going to use the option parameters. Oh, wait, before I do that, almost forgot. I have to say, every environment we're going to target endpoint, yep, is dev. Wonderful. Right. Deploy parameters, params.yaml. And so it now reads the parameter file. It uploads, it compiles the Cloudformation into the Cloudformation template, uploads it, and initiates creation just like we saw before. So if I go to the stack here, we'll see another stack being created. We'll have some cleaning up to do later on. We should see under events that things are being created. This will just, oh, this was nice and quick. We have the topic, and if we open it, it says developer topic, right? This is what we would expect it to be. We also see it here in the output, since this is a value that we flagged in our stack that we wanted to be shown as a stack output. But yeah, now sometimes you might be like, when these parameter files get more and more complex, trying to figure out if it's correct by running a deployment is very extremely tedious. So there's a way of actually rendering the parameters file and just showing what actually it would be generated. And that's called show parameters under /util. So /util show parameters, and then we just say params. And so this will run all the execution and then show you the values that it has computed for those parameters. So for example, secret was converted from alias to an ARN because that's ultimately what you need. Alias is just much easier to read. And then display term was resolved to developer topic. So now if I go back and I say here, this is actually prod, what I called it, yep. And I reevaluate the parameters file. you will see that it shows no production topic. It picked up the other one because it read it from a different file, and that's kind of how the mechanism works. So that allows you to be pretty flexible on how you configure these things. Because it's a YAML file, you can put in comments, and you have these functions. So it's a pretty powerful mechanism for creating parameter files to initialize exactly the way you want it, the Cloudformation stack from the LambdaSharp module based on which environment you might be in, and so on and so forth. So it's a pretty powerful mechanism. Okay, and I think this gets us pretty close to the finish line. Yep. So I'm a big fan of, I mean, first of all, you should parameterize your stacks, your templates or your modules. It's a lot more flexible. Don't inject hard-coded values and things of that sort. The objective when for the most flexible kind of module is to try to have it parameterized. That said, take advantage of the Cloudformation parameter capabilities by using the allowed patterns, allowed values, and so on to constrain the inputs to the best of your abilities to only values that you expect to be successful. It just narrows the opportunity for mistakes. I'm a big fan of keeping all the values in kind of a master configuration file, because then I can version it with my environment, and I kind of, in my repository, the branch, the checkout, is representative of how everything should be working, because everything is feeding off that representation. With parameter store, there's a couple of things you can run into. The first one is really the one that just freaks me out the most, because I think it happened to us once in our production environment, or maybe in our staging environment. It's incredibly hard to track down and determine that it did happen. And that is the following. You are reinitializing your parameter store values. So somewhere you're tracking them, you're initializing them. So that's happening, right? And that might take a couple of minutes depending on how many values you're updating. In the meantime, for one reason or another, CI/CD pipeline triggered the deployment of a module. It is now resolving against the parameter store. And you might be picking up, unfortunately, some old values with some new values that are not meant to work together. Right? It's not atomic. That parameter store doesn't have a notion of atomic updates. It is progressing. And so there's a real race condition. And when it happens, and you now have a stack that is effectively configured with kind of a torn configuration, means like you took the first half of the parameters from your old version and the second half of parameters from your new version, you kind of like stuck those together. That's what you're running. And maybe that works. And if it doesn't, try to figure it out, because nowhere was that ever a state that you would see. You wouldn't see it in your old configuration file. You wouldn't see it in the new configuration file, because there's an overlap of the two. So that's really, really bad. And that should be avoided at all costs. There's also the concern of throttling. This really hit us hard earlier on. Before they upped the throttling limit for parameter store, hasn't been a problem since, I believe. However, it is there. It is a clear and present danger. If your CI/CD pipeline is launching a lot of stack updates, and all of them are hitting the parameter store, you will be throttled at some point. Again, that limit is higher. I think they increased it by 10x compared to what they did before. However, it is, like I said, a concern. If you have to use parameter store references, okay, I would recommend using dynamic references, or the parameters file get param capability. Don't use this, what seems to be an earlier experiment of tying in parameter store with Cloudformation using these parameter store specific types. I would simply not recommend it. Encrypt sensitive information, goes without saying, password, access token, things of that sort. And then, remember that you can specify resources as parameters, which gives you some flexibility, making them conditional. And so they get created if you need them, or they can be passed in if some exist. And then last, I just wanted to quickly point this out. That was just a quick example. You can keep sensitive data checked into your GitHub, GitLab, whichever repo you're using. It's not a problem as long as it is encrypted. So for example, instead of secret greeting, this could be the password to a database. In order to be able to decrypt it, you have to have access to that key. The value itself specifies which key it came from. So you don't need to be explicit about, hey, use this key to decrypt that. That is implicit. So you should have an architecture where, for example, you use one key that that encrypts everything that a certain constituents need to have access to, around maybe some database information, username, password, things of that. So query, the connection string. And then you have another key for other parts of your system that other systems should. You don't use one key for everything. Now, keys cost about $1 per month. So there's that, unfortunately, just managing them. There's also a usage cost, of course, of decrypting or encrypting. Here, the decrypt is going to be more important than the encrypt, because just all the systems are decrypting at one point or another. However, it's a good idea to partition access to secrets by KMS key. It's very clean. It's very easy to manage, or a lot easier than alternatives. Now, with the one caveat, I do not have experience with Secrets Manager. And so I know that Secrets Manager actually has a document that is associated with it, which addresses the atomicity issue. It has like stage name, which again makes it a little bit easier than version numbers to ensure that you access the version that you wanted. So that might be a place where you want to do some research and see if that actually fits your use case better. So that, I think, covers it for today. And if you want to look at the code yourself, play with it, you can find it on GitHub at LambdaSharp on the serverless patterns-deployment configuration. You can find documentation about LambdaSharp at LambdaSharp.net, and of course, follow us on Twitter at LambdaSharp. I hope you enjoyed it, and I'll see you next time.